In this part, I'm going to talk about how to program a little bit more defensively in code that uses inheritance. And to do that, I want to talk about this table formatter class that we did in the last section a little bit more. One of the things that's going on in this table formatter is that it is serving as a kind of design specification for making tables. We have these methods, headings and row. In the base class, they don't actually do anything. So in table formatter, they don't do anything. But then what we're supposed to do is inherit from that and customize it. Turns out that there are mistakes that can be made in doing this as you start to use inheritance and write larger programs. One of the concerns is how do you enforce that programming interface? Like somebody might make a class where they inherit, but then they do something like make a typo, for instance. Like they say heading instead of headings. What's going to happen there is if somebody tries to use that code, like they maybe say, okay, let's make a text table format, and then you try to use it, you might find that the code just blows up later on. You'll be coding along, and then all of a sudden the thing just blows up with a not implemented error. That is a little bit problematic because the error is kind of deferred all the way into the future until somebody actually tries to run stuff on the class. It might be nice to sort of catch that error a little bit earlier. So one of the features that you can do or use in Python is something known as an abstract base class. There's a library module called ABC. This is part of Python's standard library. So I'm going to import something called ABC from there and a function called abstract method. And what you can do is recast this table formatter so that it inherits from ABC, and then it declares these headings and row methods as abstract methods. You do something like that. Actually, once you do that, I don't even need to worry about raising the error anymore. I can just put a pass in there. So what I'm going to do is implement some methods, declare them as abstract. The thing that's interesting about this is that this class will now enforce the existence of those methods. The way that this is going to work is that if somebody tries to make a formatter, like they say formatter is equal to table, text table formatter, you'll actually get an error right away saying you can't do that. You didn't implement the headings method. In fact, it'll actually tell you what is missing about your class. This could be a very useful thing if you're ever working with inheritance in a big application. Essentially, this abstract base class idea can inform programmers about what is required. And if they mess up, you can get useful error messages back. So this is one kind of defensive, strategy. If you're going to use inheritance, it's often a good idea to maybe write what's known as an abstract base class to have it enforce the existence of method. Another thing that you can do to be defensive is add a little bit of type checking to some of your functions, like this print table. One of the things that you might want to do here is do some instance checking. Like I can say, if the formatter is not an instance of a table formatter, raise a, maybe a type error or something. Maybe you could make a better error message. Must be a table formatter. What's going to happen here is it's just going to prevent people from passing in bad data to that function. I mean, maybe somebody tries to pass in the wrong kind of class or something like that. That will catch that. This is actually part of the reason for structuring the code in this way, by the way, is that this base class will serve as kind of like a point. All the child classes kind of inherit from that. You can use the base class to do things like type checking. What that type check would catch is maybe mistakes where somebody didn't inherit correctly. Let's say somebody made a class and they inherited from object instead of table formatter. That change that we made, it would catch that. So if I made a formatter from CSV table formatter, and then I tried to pass that in to the print table function, it would blow up. It would say, you passed in the wrong kind of data. Again, these are things that you tend to think about when you start writing larger programs, kind of controlling the environment, being a little bit more defensive about what objects are being passed around and how they work.